Hello again, it's Darcy from the Learning Center, and here I'm going to show you the third part of this question about using the central limit theorem. So we're going to look at part C, find the probability that the mean time of 27 random samples of golfers is between 2.3 and 2.5 hours. All right, we'll go ahead and do how we started A and B as well by drawing the normal curve. So let's get centered here. Part C. There we go. Do a sketch so we can see what we're talking about. The mean is 2.5, and we're looking for the probability that we're between 2.3 and 2.5. Okay, so let me draw 2.3 hours on here. Now, because the z-score table works in areas under a curve left of a given value, what we're going to actually be looking at is the area left of 2.5 is all this, including all this area down here. Now we can subtract from that the area left of 2.3. So we'll subtract the green part. And then what we'll be left with is just the purple shaded area between 2.5 and 2.3. So what works every time for these questions about areas between two values, the area between 2.3 hours and x equals 2.3 and x equals 2.5 equals, you'll take the larger value, so the area left of 2.5, subtract the area left of 2.3. Okay, we can definitely do that. Now, some things to consider since we're looking at our picture there is there are some things we can already know without having to do too much calculations. So we'll be able to see that since 2.5 is one of our values, 2.5 is actually the mean of the whole distribution. So the area to the left of 2.5 is 50% of the space, right? So I know that this actually equals a probability of 0.5 already, because everything to the left of the exact middle under the normal curve is 50% of the values. A probability of 0.5 is represented by a z-score of 0. We can see that in the table. A z-score of 0, you'll see in the very bottom here, it says -0. The reason it says -0 is because it's -0.01, 0.02, and so on. But at 0, the probability is exactly 50%. You'll see it on the positive side as well. Positive side, exactly 0.5. So we can know that already. I'll show the calculation in case you do this with numbers that one of your x values is not the mean of the sampling distribution. So let's find, so what we're going to do is find the area left of 2.5. We find the z, it is 2.5, which is the x that we're given, minus 2.5, you see where the 0 is coming from now, over the standard deviation divided by the square root of n. This equals 0. So the probability there will of course be 0.5, but we already knew that. It's helpful when you're preparing for a test to try to use these kind of tricks that I've got here about what are things that you already know and can be sure of, because if you have any sort of anxiety around testing, or if you find your brain goes a little blank or you forget things you already knew, this is ways to build your confidence and show that you did know that. So to carry on to do the next part, we found the area left of 2.5. Little notes like this to yourself about what it is that you're doing can help you remember that you're not finished, right? What was I actually doing? I was finding the area left of 2.5. Let's look back at my picture. Is that finished? Oh no, I still have to find the area left of 2.3 and subtract it. Give yourself that little map to what you're doing. So I did that, and now part 2. I'm going to find the area left of 2.3. Okay, we'll find our z. 2.3 minus 2.5. Remember, for that green area under the curve, we're expecting something less than 50%, so we're expecting a negative in the numerator here, so that's good. Over here, 0.4 divided by the root of 27. Once that's calculated out, we come out with a z of negative 2.5. Now, according to the table, a z of negative 2.5, we're in the positives there. Negative 2.5 is a probability of, sorry, it's negative 2.6. It's a probability of 0.0047. Very small probability, but that's fine. Again, remember, we've written our instructions about what we got to do. Okay, so now I just have to subtract those two. So the probability equals 0.5 minus 0.0047. And I'm left with the probability equal 0.4953.